Hey everyone. Uh, this one is going to cover lasering with Fusion 360. So to start with, you got to cover a couple of topics. Uh, how to set up a tool so that you have a laser that emulates what your laser can do. Then how to set up the tool path so that you can actually lays out an object, and that can happen either on the outside of your object. So if you have a square, you can laser on the outside of your object, on the inside of your object, or right down the center line, depending on what dimensions matter to you. And then how do you turn that into G code that the MPCNC or Lowrider 2 can actually make use of based on the board that you're using? So, well, to get started, we'll make it quick and dirty. Um, I do have in my settings, if I go up to my account and I look at my preferences, if you look under manufacturer, I do have cloud libraries enabled. And I do that just now because I do log in on 3 different machines, and I like to have all my tools and my post processors and whatnot follow me around, uh, so I can create G code from anywhere. Not necessary in this case. Um, Lars has a great video on how all of this works. I strongly suggest watching that one. Um, but what I'm going to do here is I'm going to create a square because it's a simple shape. So we're going to start a new sketch. And I'm going to pick the Z floor there so the top is straight up. And I'm simply going to create a rectangle. And I'm going to start the rectangle, oh, let's say here. And we'll draw it to here. There. Real simple rectangle. I'm going to finish sketch. There, now I've got a box. Now I want to laser that box. So I'm going to move from design to manufacture. Once I'm in manufacturer, you see all of these different kinds that you can make with. And if you look in the fabrication, you will see cutting. So they moved it there. Uh, and if you look at cutting, you can do a 2D profile because, yeah, basically, if you're firing a laser from a 3-axis CNC, you're doing a 2D profile cut. So I'll go ahead and I'm going to say, yes, I'd love to do a 2D profile. So I got this 2D profile started and wants me to select a tool. All right, let's go ahead and select a tool. And in this particular document, I don't have any tools. I'm not going to go through my cloud library and my local library and show you what I've already got made because that's pointless. I'm going to go over here to the plasma, water jet, and laser tool type. And I'm going to select, let's create a new tool. And we're going to call that Nik's laser. And under the cutter settings, I'm going to say that is a laser cutter. So now I got this nice big fat plasma or laser torch there. I am using millimeters because I'm aware of my measurements in millimeters. My kerf width, that is how fat is the beam at the focal point where I do most of my cutting. And I've gone through and I've measured it by cutting out boxes and then measuring the edges of the boxes. And mine is not 2 millimeters, which is the start. My gosh, that is a big, big laser beam. My laser beam coming out of the tube is 3 millimeters. But when it gets focused, it's actually down to 0.1. I get a 0.1 beam out of that thing. Sometimes a little less, sometimes a little more, but 0.1 when I do tongue and our tab and slot fitting, that setting works great. I get great fits out of it. I never have to sand. Occasionally I have to wedge a little bit, but I prefer that. Then the nozzle clearance diameter is how much is the nozzle around the work. To be honest, um, the nozzle clearance diameter I don't use because the very next thing I do after I set this is I get rid of the holder. Uh, I'm not lasering around a 3D object where I'm likely to put my nozzle inside of a piece of work to laser into it and then try to come back out of it. I'm lasering on flat stock that the laser could go from throw to throw on the CNC bed and not hit a damn thing. So I just turn the holder off because it's messy to work with. Now on the speeds and feeds, I go ahead and leave that default because there's something else that's going to take over here. It really depends on your type of tool or your type of cut that you want to do and the material. So this is going to change all the time. So I go ahead and leave that alone because on each tool path I create, I'm going to pick a new one. Um, and then I have the opportunity to send some um, functions to the post processor, and there isn't really a whole lot of variables here that you can play with, so I leave it alone. All right, so there. Now I've got a 0.1 millimeter laser cutter that says Nik's laser. So I'm going to go ahead and pick it. All right, now I've got it picked. Um, you see it here, and it says what cutting mode. So if you look for lasers, you've got a couple of modes. You've got through, and it's got some various quality settings. This is kind of important. You've got etch, and you've got vaporize. These modes get passed through to your post processor. Now your post processor can choose to use them, or it can have simple laser on, laser off. Um, a good post processor will have all of these settings: the high quality, medium quality, the low quality, and etch and a vaporize. The one I use has at least three. It has the through, it has the etch, and it has the vaporize. So I can have different power settings based on which one of these I select, and the post processor will turn that into the right command in the pulse width modulation to your laser and give you different levels of power. It will not be as cool as light burn. Light burn has immaculate settings for different laser powers because it's built for just lasering. But this is usually good enough. Usually you find yourself with a really good etching mode that makes nice dark lines on whatever material you want. And then you find the power setting that works best for blasting through the material. And that I usually set to vaporize and etch. I haven't ever done this before, but I use vaporize and etch pretty reasonably. So in this case, I want to vaporize because I want to cut. And in this profile, I happen to know that my cutting feed rate is I'm going to go 5. I'm going to cut acrylic 5 millimeters a second. It's supposed to do this for me. I may have to do this I may have to do the math. Is it not going to do the math for me? Fine. No, some of these will do the math for you if you put in different measurements. So let's see, 5 times 60 is 300 millimeters per min. There, 300 millimeters per minute is what it takes. And then my lead in feed rate and my lead out feed rate, I'm going to leave alone because I'm actually going to go to the geometry and say, I want to cut this box. And then I'm going to look at the start inside, start outside. You can also change that by clicking the little arrow. You notice it chooses whether it's going to cut this box and maintain like this. If I have on start on inside, I'm cutting this out to discard it, and I want this hole to be the exact measurements that I drew my rectangle. If I click it this way, then I'm assuming I'm keeping the inside, so I will cut just a kerf width outside those dimensions so that my piece that falls out is exactly that dimension. You can decide which way you want it. I usually cut it right down the middle. And the heights I don't mess with because I set the height on the laser myself. My laser likes to be about 6 millimeters from the tip of the nozzle to the work surface to get the focal point in the best place. And I did a ramp test to figure that out. So I will do that myself and not worry about any of this. Um, when it comes to the passes, here's the compensation. I ask it to go center, which you notice puts the red box right on the center. It means I just want it to cut exactly where I told it. I will have a little bit of material missing on the inside part as well as the outside part, but it's such a small kerf that I don't care. Um, Preserve order also preserves as I select the lines. That's the order in which it does the lines. Very useful if you're going to be cutting the inside part of a part. You want to cut those out first before you cut out the main part so the main part doesn't fall through and shift places and cause you to cut in incorrect places. So I'm not going to use that right now. And then when it comes to lead-in entry, you have these little, almost like a little flight pattern of an airplane. You kind of zip in and then start cutting, and then when you're done, you kind of zip out, and it does the laser on and off motions during those lead-in and lead-outs. So by the time it reaches the edge of your work, the laser's already ramped up to power. Um, and I find that creates odd little cuts. I mean, if you do it right, they're actually kind of nice, and then you're never going to have underburn or overburn. Um, but you'll have little tick marks where you can see the laser starting and stopping on your work. For me, I turn them off because I go ahead and I edit the G code in a way that I know works for me. But otherwise, they're kind of nice. Um, yeah. Anyway, so let's go ahead and hit OK here. It creates a quick little work, and there's really not a whole lot for you to see. It shows you right here. Laser's going to start up here. It's going to come down, and it's going to go around the circle, and it's done. So let's go ahead and look at the next bit. We've created a toolpath, pretty simple. Let's go to the post processor. And if you look, this is the path that your configuration folder is in. This is the path that you're going to output your code. But this right here is your post processor. And I have 3 of them. And I'm going to show you some differences between them. This is the very first one that I got off the forums way back 3 years ago. And this one is great for milling. I just found it nice for it. If you look at the post processor properties down here, it has a macro for laser on, laser off. And so this is where I put my M107, and I use the fan 2 output on the Rambo to turn things on and off. Some boards, if you only have one fan, it's called fan 0. And just typing in M107 and M106 is good enough because it defaults to the first output. I need it to be P2 um, uh, in this, so I get fan 2. And then this is where I pick my power. So I use S255. This was for my diode laser. I wouldn't do this for my CNC. I would burn it whatever it takes to get 10 milliamps. And for me, that's about 144. So I changed that to S144. But you notice I only get laser on, laser off. So that's pretty much going to be either etching only at 1 power, or it's going to be cut through at 1 power, and I can't do both. So this post processor wouldn't be so great for laser. It generates good code, but so I'm going to go ahead and move this to one of the ones from Guffey that uses Marlin 2. And in here, you see I get laser off, which is my M107 P2, but I get one for etch, one for through, and one for vaporize. So now it's paying attention to what I set in Fusion, and I can set different strengths for the different laser powers in my tool. So I can have a tool for etching, I can have a tool for cutting, and I can have a tool for something else. The etch and through are probably going to be uh, different levels of etching. Um, in Fusion, usually you're making mechanical functional parts. You're not doing graphic arts and whatnot. So there may be a reason for you to have 2 strings, but I find an etch and a vaporize very useful. And a vaporize, I take it all the way to the max power I should be using on my laser. For an LED laser, that's 100%. Just S255 and let it go. For a CO2 laser, you usually want it about 80% of max power to maximize the length of your tube. And so since I can do 12 milliamps max, I bring it down to whatever makes it take 10 milliamps. And that's what I call my maximum punch through. And I try not to step over that for any reason. Occasionally I'll find a stubborn piece of material and I'll make the election to go ahead and burn it hot. but it does, you know, reduce the life of your tube. Anyway, so that's what the post processor gives me. So now depending on what I picked, and I picked vaporize, it's going to use this setting. So if I look at it, I actually modified it to about 130. So I have used this one recently with the CO2 laser, and because right now I have the through still set at I think 255, right, or 200. Okay. Anyway, so I pick it. This whole naming thing is really, it's inside the metadata of the G code. It doesn't show up anywhere, so we'll just call it Bob. Um, and we'll go ahead and hit post. And it'll ask me where to save it. And we'll see, we'll put it right there. We'll call it Nik Test dot G code. I like calling it G code for fun. And then if I do my file browser, and I bring up Nik Test, this is the output I got. So you can see that I didn't save my document. It was left untitled, so it put that comment in there. This is my first setup. Again, I didn't name it, so it put that in there. So it's going to do all this stuff for me and kind of label things out. Um, it's got the ranges that I'm going to go. Looks like I went 70 by 60 on my little deal, my little rectangle. So it's letting me know what ranges on the table are going to get used. I did tell it in my post processor. Let me take a look at this real quick. This is important. In this particular post processor, it asks job, go to 0 at the end, but then reset on start. See this reset on start? This is whether or not I can manually move my laser to where I want it to start and have the G code respect that. So if I look at my G code, if this will come up here, it actually puts the G92 X0Y0Z0 to say, hey, wherever you're currently at, that's your new 0. So you can have it not put this command in there if you want absolutes. And this is where you would set it in the properties of the post processor. And then it puts all these fun things in there. Look at all this extra goodies that he's telling me about. I'm using cutting mode vaporize, and um, it slaps some more stuff in there. This is one thing that bugs me about this particular post processor. The M117 command that it stuffs in there is the LCD screen. It's going to banner something to the LCD screen, and you got to press the LCD button to continue. It starts a pause. It says I'm about to work. Kind of cool if you're going to do a production of, say, let's say you're cutting a couple hundred Christmas tree ornaments, and you want to start it up and have it go back to the beginning, and then put the new piece in there and hit the start button again and go back to the beginning. Awesome for that. I'm usually doing one-offs, and so I don't really want to interact with the LCD. So I use a post processor that doesn't put that in there. But it's kind of cool. I mean, the guy took some time and wrote this post. This is, I think, the Guffey post processor if you watch the forums. So it'll stick that in there. Other than that, then it's going to go through and go to the Z and everything that I specified. Here is where this doesn't matter. It's going to raise the Z up, and if you have a diode laser mounted on there, the diode laser is going to go up, but it's going to return back to the 0 that you started on before it gets started. It's like it's trying to skip possible collisions. Anyway, then it's going to turn the laser on. There it goes. Turns my laser on, and it runs out to um, uh, the 1 position. So 1 millimeter out, goes to 61, goes to 71, comes back to the 1, and then turns the laser off right there. And then does a rapid movement back up to the clearing height. But look at all these comments. It sticks all these nice comments in there. So if you wanted to go back through and edit all your stuff, this code is a lot easier to read. So it's kind of nice. But then see, look, it banners the screen again and says, hey, your job's done. Yeah, but usually your LCD or your software does that for you anyway. So it's just one more reason to come up and have to press the button on the LCD. So I try to avoid that particular one. It doesn't make as clean a mess. So the one I picked, some guy did this plasma cutter. It's supposed to be for milling plasma and laser. And it also has vaporize, etch, and through and off. It also has, I don't see the, would you like to start at 0 and finish? So let's go ahead and post process with this one, the exact same file, and we'll call that Nik Test 2. So we'll see what different post processors do, and I'll bring up that code. So look at this, the same exact thing. Didn't have a setting for, hey, start at the beginning, but it did. So that's in there, and it's something I didn't have access to. It puts a little bit of a documentation right at the beginning, but then it just goes right to work. And notice, oh, this one here also has the M117 command, but it does a lot less commenting. Um, yeah, there you go. So you can see the different post processors, and you can have multiple post processors in your post processor file or your folder, and have them up on the cloud. You know, if you go through Lars's video. But different post processors will interpret all the commands that Fusion would throw it and turn it into something that's Marlin-ish. And what does that mean? That means that uh, it knows that Marlin respects the G92 command, whereas, say, Gerbil might not. Gerbil might not respect that command. Now, in this case, yeah, it's a pretty popular command. But if there's other things that your particular version of your firmware doesn't support for G code, that Fusion's going to say, hey, I think I'm working with a professional uh, industrial system that uses all the G codes. It's going to grab some things and make changes to the code on the fly. It's like a text editor on the fly to produce code that your particular firmware can understand. And that's why you want a Marlin-based post processor for the MPCNC. Other than that, that's kind of how this works. Let me know if you have any questions. I'd be happy to answer them. I know this was kind of quick, but this is how I go from Square to creating a laser tool to creating runnable G code that I can put on my SD card or however you guys want to do it.